Hello, this is Sankareshwari, Assistant Professor, Department of Information Technology, Madurai Sivasi Nadar Pioneer Meenakshi Women's College, Puvandi. Now, in this session, we are going to see in detail about cryptography and network security. First of all, what is meant by cryptography? The encryption is essentially important because it secures data and information from unauthorized access and thus maintains confidentiality. Now I am going to take help of an example or a scenario to explain what is cryptography. Let's say there is a person named Andy. Now suppose Andy sends a message to his friend Sam, who is on the other side of the world. Now he wants to send his message to be private and nobody else should have access to the message. He uses a public forum for sending his message. The main goal is to secure this communication. Let's say there is a person named Yves who secretly got access to their communication channel and tried to change the message. Now, this is just a small example. So, how can Andy be sure that nobody in the middle could access the message sent to Sam? That is where encryption or cryptography comes in. So, what is cryptography? Cryptography is a practice and study of techniques for securing communication and data in the presence of adversaries. Alright, now that we know what is cryptography, let us see how cryptography can help secure the connection between Andy and Sam. So, to protect this message, Andy first converts his readable message to unreadable form. He uses keys to encrypt this message. In cryptography, we call this as a ciphertext. Andy sends this ciphertext or encrypted message over the communication channel. He won't have to worry about somebody in the middle of discovering his private messages. Suppose Yves have discovered the message and he somehow manages to alter it before it reaches Sam. Next, Sam would read a key to encrypt the message to recover the original plaintext using the decryption key. He would convert the ciphertext or the corresponding plaintext. After using the key for decryption, what will come out is the original plaintext message. It is an error. Now, this error is very important. It is the way Sam knows that the message sent by Andy is not the same as the message he received. Thus, we can say that encryption is important to communicate or share information over the network. From this figure, let us see the components of public key algorithms. The plaintext. This is the message which is readable or understandable. This message is given to the encryption algorithm as an input. The next is the ciphertext. The ciphertext is produced as an output of an encryption algorithm. We cannot simply understand this message. The next one is encryption algorithm. The encryption algorithm is used to convert the plain text to ciphertext. Next is a decryption algorithm. It accepts the ciphertext as input and the matching key. The key may be private or public and produces the original text. Next one is a public key and private key. One key, either private key, that is secret key, or public key, that is known to everyone, is used for encryption and other is used for decryption. The message exchanges using cryptography involves following steps. At center side, the message is converted into an unreadable form using an encryption algorithm. The message in unreadable form is called as ciphertext. The ciphertext is sent to the receiver over the communication channel. Since the message is encrypted, the attackers cannot read the message. At receiver side, the message is converted into a readable form using decryption algorithm. The message in readable form is called as plaintext. Then the receiver can read the message. Cryptography techniques broadly that may be classified into two types, that is symmetric key cryptography and asymmetric cryptography. Let us see public key cryptography or asymmetric cryptography. The public key cryptography is an encryption technique that uses a paired public and private key, that is asymmetric key algorithm for secure data communication. A message sender uses a recipient's public key to encrypt a message. To decrypt the sender's message, only the recipient's private key may be used. There are two types of public key cryptography are RSA and digital signature algorithm, that is DSA. Public key cryptography is also known as public key encryption, asymmetric encryption, asymmetric cryptography, asymmetric cyber, asymmetric key encryption, and Diffie-Hellman encryption. The public key cryptography facilitates secure communication through an insecure channel which allows a message to be read by the intended recipients only. For example, A uses B's public key to encrypt a message to B, which can be decrypted using B's unique private key. The public key cryptography maintains email privacy and ensures communication security while messages are in transit or stored on mail servers. The public key cryptography facilitates confidentiality, data integrity, authentication, and non-repetition, which form key information assurance parameters. The public key cryptography is slower than secret key cryptography or symmetric cryptography methods due to high computational requirements. Unlike symmetric cryptography, public key cryptography uses a fixed buffer size that depends on particular and small data amounts which may only be encrypted and not chained in streams, because a broad range of possible encryption keys are used. Public key cryptography is more robust. Now, we will discuss about asymmetric key encryption or public key cryptography algorithm. The encryption process where different keys are used for encrypting and decrypting the information. RSA is the most widely used form of public key encryption. RSA stands for Reversed, Samir, and Adelman, the inventors of this technique. This algorithm is invented in 1978. Using RSA encryptions, messages are encrypted with a code called a public key, and it can only be decrypted by another key known as private key. Let us see RSA algorithm. How does it work? RSA algorithm mainly consists of 5 steps. The RSA algorithm uses only prime numbers. So, first we have to choose two different prime numbers, that is P and Q. In the next step, we have to calculate the value of n. The value of n can be calculated by multiplying the value of P and Q. So, n equal to P into Q. Next, we have to calculate the z or pi of n value by using the equation, that is pi of n equal to p minus 1 into q minus 1. In the next step, we have to choose a random integer, that is c. E should satisfy the two conditions. The first condition is E should be in between 1 and pi of n value. And the second condition is GCD of E comma pi of n should be 1. These are all the main steps for the RSA algorithm. Here in RSA algorithm, E considered as a public key. Next, we have to calculate the D value. Here, the D value considered as a private key. So, how to calculate the D value? D value can be calculated by using E into D equal to 1 mod pi of n. Based on this equation, we can calculate the value of D. Finally, we move to the encryption step. In the encryption step, we are calculating the ciphertext, that is C, by using the public key E. So, here we have the formula for encryption, that is C equal to m to the power E mod n. M is the message. The next step is a decryption. The decryption can be done by using the private key, that is D. Here we have we have a formula for the decryption, that is D equal to C to the power D mod n. So from this decryption we will have the plaintext as well. Let us demonstrate this algorithm by using a simple example. Here we have the parameters, that is p equal to 3, q equal to 5. From this parameter value, we have to calculate the value of n, pi of n and e and d. The message will be given as 2. From these parameters, we have to calculate the ciphertext C. So, how to encrypt the message? We are having the parameters, that is p equal to 3, q equal to 5 and m equal to 2. In the first step, we have to calculate the value of n by using the formula p into q. Already we have p equal to 3 and q equal to 5. So, p into q means 3 into 5. So, we obtain the value of n is 15. In the next step, we have to calculate the pi of n or z value. The pi of n or z value that can be calculated by using the formula, that is p minus 1 into q minus 1. P minus 1 means 3 minus 1, that is 2. Q minus 1 means 5 minus 1, that is 4. So, 2 into 4, that is 8. So, we have the value of pi of n or z is 8. In the next step, we have to choose a random integer, that is e. Already I told you that e should satisfy the two conditions. The value of e should be in between 1 and pi of n, and GCD of e and pi of n should be 1. So, we will take e as a least prime number, that is 3. So, if we let me check the e value 3 with the two conditions. The 3 is in between the value of 1 and 8. The first condition is satisfied. And the GCD of 3, 8 is 1. Absolutely, the second condition is also satisfied. So, we will take e as 3. Next, we have to calculate the value of d. We may calculate the value of d by using the formula ed equal to 1 mod pi of ed mod pi of n equal to 1. We will try different prime numbers for d. In RSA algorithm, all the values should be a prime number. So we will take the D as a 3 only. 3 into 3 mod 8, that is the value is absolutely 1. So the condition is satisfied. So we will take D as a 3. In the next encryption process, we have to encrypt the message M by using the formula C equal to M to the power E mod N. We have this E value as 3 and the message is 2. So C equal to 2 power 3 mod 15. We obtain the value 8. Next is the decryption process. From this decryption process, we can check the original plaintext is obtained or not. The D equal to C to the power D mod N. So C is 8, D is 3. The N value is 15. So 8 to the power E 3 mod 15 equal to 2. This converts the ciphertext back into the plaintext B. In this way, the RSA algorithm is used to encrypt and decrypt the message. The next one is a secret key cryptography or asymmetric key cryptography. In this technique, both sender and receiver uses a common key to encrypt and decrypt the message. This secret key is known only to the sender and the receiver. It is also known as a secret key cryptography. Now we will see the working mechanism of symmetric key cryptography. The message exchange using symmetric key cryptography involves the following steps. Before starting the communication, the sender and receiver should share the secret key. This is a crucial problem. This secret key is shared through some external means, that is some communication channel. At sender side, sender encrypts the message using his copy of the key. The ciphertext is then sent to the receiver over the communication channel At the end of receiver side, the receiver decrypts the ciphertext using his copy of the key. In this symmetric key cryptography, the sender and the receiver shares a common key. So the sender and the receiver known about the particular key. After decryption, the message converts back into a readable format. In the encryption process, the message will be converted into the unreadable format, that is ciphertext. In the decryption process, the message converts back into the readable format, that is plaintext. Here we have some of the algorithms that uses symmetric key cryptography, that are Advanced Encryption Standard, that is AES, Data Encryption Standard, that is DES. Here we have some of the advantages and disadvantages over the symmetric key cryptography algorithm. Here we have advantages over symmetric key cryptography. The symmetric key cryptography algorithm is very efficient, that is compared to asymmetric key cryptography algorithms. It takes less time to encrypt and decrypt the message, unlike the public key cryptography. These are all the advantages of symmetric key cryptography algorithm. Now we will look at the disadvantages of symmetric key cryptography. The symmetric key cryptography disadvantages are the number of keys required is very large. That is, if we have the n people, means if n people want to use this technique, then n into n minus 1 by 2 secret keys are required. The number of keys required is very large. For 1 million people to communicate, a 500 million secret keys would be required or that would be needed for encryption process. The second disadvantage is sharing the secret key between the sender and receiver is an important issue. While sharing the key, the attackers might intrude. So that is the problem in this symmetric key algorithm. So these are all the disadvantages over the symmetric key cryptography. Thank you.